So I go through agenda. Seems a lot to cover. I will try to speed up where necessary and really focus on trying. There are two things I want to achieve. Demystify some of the terms. It's actually good. Maybe people came WebAuthn actually understood WebAuthn, but when we talked to them the other sessions, WebAuthn was shown in different sessions, and people were like, "What is WebAuthn?" For those in the WebAuthn discussions, that seems like it's been kind of around for a while, but it's actually one of the fastest moving standards that we've seen in recent times. I'll talk through a whole flow on WebAuthn. We're going to focus on WebAuthn, but I'll give the overall context on what we're trying to solve. We'll talk through also upgrading from FIDO U2F, because that's been a hot topic as well. Like what happened to FIDO U2F? Like everybody says, we don't talk about FIDO U2F anymore. What happened? WebAuthn is actually a natural evolution of the standards. So we'll go through a little bit of that as well. So where are we at? So we talked about, if those were you in the previous sessions, we talked about MFA 2.0, but MFA 1 was all, what, KBA, password, what it is, shared secrets. So we're moving the entire industry away from shared secrets. So this is where we are. We're at MFA 1, which is shared secrets. MFA 2 still has shared secrets. We need to get something else. So the entire basis of shared secret, why they're bad, everybody knows why they're bad, but technically why is it bad? Because it's not just a crappy user experience, but on the back end, you have all these shared secrets, which is one compromised server, then you have a lot of problems. So what we need to do is to move to things that we know are secure. So we want to use cryptographic proof from where the user's perspective. So we'll use public key crypto as long as you can guarantee that the private key is not easy to be extracted, cloned, or copied, then this is a good place to start, right? So you provide cryptographic proof that you are that person using whatever device that you have. And if you took the server down and you took all the data away, a set of public keys, which is not super useful. Maybe privacy issues, but in general, not a security problem. So that's what we're talking about. So the whole scope for web authentication is about moving to attested scope public key credentials for the users and for web applications. This is the foundation of the work that we've done, all the way from FIDO, all the way now to web authentication. That's the foundation. We're not building an entire system with shared secrets. So that's, if there's one takeaway, this is a web takeaway. We're building this entire system based on public key crypto. Okay, so we talked about a couple of these things that we solved with two-factor authentication, strong two-factor authentication. What do we want to expand? We want to expand to all modalities of authentication. Either strong single factor, again, strong single factor does not, in this case, for the FIDO 2.0 discussion, is not based on shared secrets. Right? Even first factor is not based on shared secrets. We talk about multi-factor authentication. Authenticator can do more than just possession of the device. You can do PIN, you can do biometrics, you can add on whatever modality you want as a factor. So we want to cover all the use cases in FIDO 2. And we're getting there. So how do we build all these things? We took these three basic principles that we started with, the FIDO principles, which is we've got to make it simple. We cannot make security difficult. If you make it difficult, nobody's going to use it. And even if the most secure system, no user is going to use it. But of course, you've got to make it secure as well. You can just create something that's super easy to use and based on shared secrets and then expect you to get a better result. So public key crypto, obviously, all the leading browsers are focusing on this, which is the origin checking. I'll go through at a high level what the protocol does with that, which is important. Presence, so this is actually one step further than smart cards. For those of you who know, I think in the previous session, MFA 2.0, what was an MFA device? A smart card is an MFA device. But we actually take it one step further from a smart cards because you actually have to show intent of action from the user. So in the case of the FIDO protocols, you have to show intent. Whether you are touching your finger over the fingerprint sensor or you touch something, like there's intent. And that's one step higher than smart cards today. And then obviously it needs to be scalable, right? Smart cards reach kind of a limit, and then nobody wants to install more middleware drivers and all these other things. Natively supported is a critical element. You hear many sessions from Google and Microsoft today that builds upon all these topics on web authentication and FIDO 2. And finally, this is also a privacy-preserving protocol. which is really critical to understand. We're not just building things and then all these services decides to share information or have a way to share the share secret, which is a problem as well. So we don't want that to happen. Okay, so now we get to demystifying what this is all about. The FIDO 2 specs is broken into 2 separate components. For almost everybody in the world, besides the big platform vendors and the vendors building the authenticators, you really don't have to focus all your time on the CTAP protocol. That's a client to authenticator protocol. Where everybody needs to focus on and think about is web applications, right? You're all building web applications, you build native apps for your customers. You're going to be focusing most of your time on the right side, which is the web authentication APIs. So, quickly about CTAP. CTAP is an evolution of how we thought about FIDO U2F. I'll go through that in a few slides. But the way that you talk to your authenticator, external authenticator, there are 3 ways that's approved in the specification: Bluetooth, NFC, and USB. And so as you think through what it means to build your system and what you allow, what you don't allow, this is the criteria right now for external authenticators. Of course, the platform OS can have their own built-in authenticators, and that's part of the journey. I'll explain that in a second. But essentially, if you need to use your external authenticator to bootstrap something, that would be a good option. And then you can use your built-in authenticator that the platform provides. One of the key criteria is obviously the platform working with the web servers, which is the FIDO server. And this is what we want to standardize. So as long as every application can call the same APIs and it applies to all the browsers and even the OS vendors, then we're in a very good place. So while the CTAP protocol really focusing on the platform and the OS and the browser, talking to authenticators, which most of you shouldn't care about because there are very few of them, everybody should care about this piece because you're going to have Google APIs, you're going to have Microsoft APIs, and in some maybe distant future, maybe you have Apple APIs, we don't know. Then you can do some work with using your application on any of the browsers. They all work. So today, just a quick state of where we are. Today in Chrome 67 and Firefox 60 supports WebAuthn today. It's shipping. There's really much progress in the Microsoft space for Edge, and I'll show it in a second, actually. But this is, for the people in the previous session, 3.0, for those of you on the early adopters, cutting edge, it's here. So a little bit more on the U2F, what happened, why did we change course? So in the FIDO U2F, and I did the talk last year and say, oh my God, I'm going to do this again for this year. No. FIDO U2F was lumping everything. So if you notice, everything was just U2F. People were just so confused. Like, is it the U2F? It was very simple in one sense. U2F JavaScript API, U2F raw messages, U2F authenticators, everything just seems U2F. But in the new model, which is very important to understand, the web authentication APIs work with U2F authenticators. So people who have deployed U2F authenticators can still use it with WebAuthn. Why? Because WebAuthn, as a spec protocol, is backwards compatible. This is a very key criteria here. And obviously, you have FIDO 2 authenticators that have additional capabilities. We'll talk about additional capabilities in a second. But this is a foundational piece. If there's another slide that you should remember, is this one. Like, we should all move to web authentication JavaScript APIs because it's ready, and hopefully by fall, there'll be 3 and maybe 4 browsers, like supports out of the box. And you notice that CTAP, U2F was renamed CTAP 1. So that clears indication that we thought about the backwards compatibility aspects of this. And from the web app perspective, you don't have to worry. It's the same JavaScript. The platform vendors and the browser vendors are just going to give you the set of APIs. You just call them. You don't have to worry about everything. All the magic happens in the background, which is really good. I'll talk about a very interesting topic that has been bubbling up in many of the work groups, both in FIDO and web authentication, which is about attestation. as we start to think of the modality of having the authenticators do more things, not just second factor, but first factor, multi-factor, it becomes quite important to think about the authenticator as making risk decisions. So the attestation gives you information about the authenticator, who is made, where it's made from, characteristics of the authenticator. Does it support, say, whatever, Bluetooth or NFC? This is important for some, but actually applicable to all. Because ultimately, as a relying party or service, you want to improve the user experience. So if you have more information that you know about what the user is using for the authenticator, you can make some better decisions on the UI or the prompts or the flows. So people used to think of attestation as whether it's a genuine device, which is true. It is still a very valid use case for services that says, I must use a device from X manufacturer that was certified at certain level, whether it's common criteria, FIPS, you name it, FIDO certification, all these things. So those are still important because you want to genuinely identify them. But there are other things that you can think about on attestation, which is everything that you get from how the user is registering the authenticator during the first initial process. So I want to call this out. This comes out a lot in the specs, things like attestation objects and attestation signatures. So important to understand what attestation is. It's part of the spec. So kind of getting familiar with this terminology is actually quite important. The other concept in FIDO 2 is resident keys. Now this is like, this is the entire motion that we started the FIDO 2 journey about resident keys. And we wanted to solve the first factor and multi-factor. And we couldn't really do that with the FIDO U2 web protocol for a lot of reasons. But one of the main reasons is that the keys was not stored on the authenticator. And if you didn't store the keys on the authenticator, you always needed to ask for some type of first factor to identify the user so that you can start the journey. And so that's why FIDO U2F was a journey in using username and password as a bootstrap, and then you take it on to strong second factor. So with resident keys, we changed really how we think about use cases now. Sort of you can think of like issuing a badge or a card with your credential, and now you can use it to log on to online services. So it's a slightly different way to think about it. So why is that important? So we talked about one type of authenticator doesn't solve with all use cases. So by allowing us to have resident keys, we open up more use cases. So one of the use cases that we all have heard about, in fact, over and over, I was in a couple of sessions yesterday as well, about roaming profiles, ephemeral user, retail use case, workforce user, retail, all these things. This allows us to get into some of those use cases. So you can think of a tap and go experience with your authenticator, your badge. So today, most solutions today are like a static credential. It's, shared secret again. So a lot of solutions today in the market are like shared credential with, a peer and then tap or whatever, some type of static credential. Most of your physical access systems are all static credentials, if you just didn't know. So when we have the ability to use public key crypto in new systems, you open up more use cases, and this is great. We also have the whole notion that we want to use, the authenticators built into your devices, your iOS devices, your Android devices, your Pixel books, your Windows Hello, all these things, which is all great. But again, authenticator is bound to the device, so if you need to change device, lost device, what do? Do you go back to KBA again? Do you go back to MFA 1? No. You want to make sure that you maintain the high level of assurance. And so bootstrapping is a critical element for having resident keys. This is a quick flow. I want to show the latest insider build for Windows, and this is the Edge flow. We're showing here that username is resident keys, and in this case, you need to have the MFA option here. This is actually all provided by the browser. This is the latest Edge browser. I don't have a PIN. The site says I need to have my MFA. It forces you to set up the PIN. You take an action. You touch the device or biometrics, whatever. Then you take the action again, and then you're authenticated. So this is a flow that's we're building on, and all major browsers will have this type of capabilities. Notice none of this was provided by any authenticator vendor. This is all built into the browser and the platform, and it's what you want. You want to just call the service and say, I want to have MFA for this user, and here are the requirements. So for example, the requirement for MFA is it's a UV parameter, user verification, and I want it to be present. And then you kick off this flow, and that's it. So quick highlights. This is a flow that is almost identical to the FIDO U2F for those who have been in previous sessions on that. You send a challenge. The challenge is, obviously one time. That prevents the replay. In this new case, we have the client, which is the browser, validate the API ID with the origin. Origin, obviously, you are getting to the origin. You are checking that. You send to the authenticator the API ID, the hash of the origin challenge, and this is where it binds everything together because the signature is needed. Create the public key, send it back, attestation object. So everything goes back to the service. You can make a decision on what you want to do with the authenticator in the future. This flow is applicable to both external as well as built-in. So the flow is exactly the same. And then you store the public keys and so on and so forth. So I'll show the authentication demo. In this case, same thing. You need to log in. You need to present with MFA, in this case, as a device that you have. So presence of the device and something you know on the device. In this case, obviously the PIN is not sent across the wire. It's not like a password. It's local to the device, just like your iPhone or your Android. Same thing for biometrics. If you do on-device biometrics, you don't send the biometrics anywhere. And then you're successful. So again, these flows are available today. You can actually do a lot of cool testing and demo and even build services around this. So I'll walk through the second factor flow, and then I'll talk about the first factor flow because that's very interesting. So in this case, this is the FIDO U2F flow. You send the credential ID. The credential ID is, in essence, you are not storing the resident keys. The credential ID will send back to the authenticator, and the authenticator will actually either unwrap it or get the private key or derive it, and then you can sign it. So in this case, as a second factor, the RP needs to know which credential to send to the authenticator, which is a key difference. You need to know what credential to send to it. And how you know the credential is for this user that's trying to authenticate is because you have used the first factor, like a username and password, for example. But after you get that, you do the same thing. You sign it. Again, you sign across everything. You sign across the origin. You sign across the challenge. And you check the origin. So I missed out one part where you check why do we care that the origin's in the signature? Because then you can verify it's actually from you and not some other bad site.com. That's why origin is in the signature, which is a critical element that we never had in previous protocols, any other authentication protocol before. So this origin checking is a very key element to the FIDO protocols and obviously to the WebAuthn protocols. So what's different in the MFA flow or the single factor flow? Notice that as a relying party, you're not providing the credential to the authenticator. That's a big change. You have new flows now. You have new use cases that you can solve. And when you finish with checking that this authenticator knows is for this RP, how does it know? The authenticator actually keeps a list of all the credentials for the RP ID. RP ID standing for Relying Party ID. And guess what you do? You return the credential ID and the user handle. That's the magic. So I pause here. This is a huge step forward in the spec, allowing for the credential ID and the user handle to go back. And that means you can create a lot of interesting flows with a lot of solve a lot of different interesting use cases. And then obviously as a service, you can use the credential ID as one of your filters to find the user, or even better, there's a user handle, which is sort of your user ID, so to speak, and you can find the user as well. So in this case, you can literally, the workflows that we've seen today, on the latest Windows 10 and Azure Join, is you walk up to a shared kiosk, possession of an external authenticator. You walk up, you tap, you log in all the way through. From Windows login all the way to federated login to OpenID Connect to the all the web apps. So you get to some very interesting flows. We talk about shared devices, roaming devices, people that don't know what they use tomorrow. We get to some very interesting use cases. And obviously, we get to MFA as well. So we actually don't even have to ask the user for username at all. Like, notice there's no username flow here at all. You don't even ask the user a username. And you use it as a device and something you know, like a PIN, or who you are as a biometric. So that is your whole flow. Yeah. Yes. You sign a signature, the signature goes back. I was trying to not have a very complicated diagram. For those who have a very complicated diagram, we have many different sites I'll show in a second that you can read the spec. The spec is very, very interesting. I think it's a bit more interesting than the 663-3. But it's all fun. It's for fun. This concept is identical to how most of you, if you were familiar with the FIDO U2F, these are the two outstanding parameters that of importance in the new flow. All right, I gotta speed up a little bit here. So what do we do with the existing FIDO U2F credential? Pretty much everything's the same, but there's one thing that's different. The hash of the RPID is used in WebAuthn. In FIDO 2, it's the app ID. So it's a bit of a mismatch. You can see, you can kind of see it here. New registration with an existing U2F authenticator. But it kind of breaks down if you already registered a U2F credential and you're going to use it against a WebAuthn JavaScript API. Why? Because the hashes don't match. So how do we solve this? We thought about this. Good. We introduce an app ID extension. So we put the app ID as a parameter in the extension converts it, makes it available so that it reads correctly for the WebAuthn APIs. So the good news is that if your users have existing U2F authenticators, they work with new registration, no problem. If they've already registered and you want to use, and you built a new WebAuthn server, and you've built all your web apps to do WebAuthn, then you're going to call this app ID extension, and everything will be hunky-dory. So that's something that I call out. We have, it's in the specs as well. But again, the nice thing, a lot of the specs right now are all being bubbled up into the 3 major browser APIs. So if you write against one of the browser APIs for web authentication, you get almost for free. I wouldn't say everything works, but almost for free. All the other browsers just kind of works, which is really nice. This is kind of a parting thought, which is when we get into this new dynamics for FIDO2 credentials, it's super important that you understand we are moving away from shared secrets. And we move away from shared secrets, which means that we don't have this one-to-one mapping. Our user has a password. I changed the password. You have many, many credentials that you can associate with the users. And you actually want that. Because if you don't, guess what you're going to fall back to? You're going to fall back to something that you don't want, that you start this journey to do away. And so we think of this new model as something as a thought, food for thought. You need to think of everything that you have can be FIDO2 enabled. So you're going to think of an ecosystem of external authenticators, built-in authenticators, all bootstrapping each other to get away from shared secrets. And the only way we can actually get this to be successful in the adoption perspective is to think of the full account lifecycle. Many discussions have been about full lifecycle, ID proofing. They're all connected. Because once you issue out a FIDO credential and you want to stay a FIDO credential, you better make sure you have more than one. Otherwise, why even start the journey? Just might as well go back to MFA 1 or something. So I'll wrap it up. There are many demo sites. I'm just giving 3 examples here. We have it, Microsoft have it, Google has it as well, FIDO has it. I encourage you to see all the demo sites. They're all working. You can try it on Chrome. You can try it on Firefox. You can try it on Insider Build for Microsoft. All the libraries are there for you to build all these things. You can see some of the services already thinking about it. MasterCard has a reference server. There's going to be a lot of reference server around. People have also built it from the specs. It's not that difficult, actually. So I would encourage everybody to start to think about this thing. If you have an existing U2F implementation, I would start thinking of how you move to web authentication. I think it's going to be a critical path for getting everybody on the new train. Final thoughts would be, I'm just summarizing up the key points is to make sure that we move to web authentication versus the U2F JavaScript APIs. And think of the new flows. You're definitely going to need more than one authenticator in this new world. Thank you very much.